Has anyone ever heard that Java is slow? Hands up. Okay, so back then when I start my journey with programming, some of my colleagues choose to go with C++. So there is reason why the rabbit has the C++ shirt. And at the time we didn't know much, so one of the metrics we know to compare to programming language was the execution time. And basically that was it. So nowadays I don't hear much often that Java is slow, maybe because I don't talk with C++ programmers anymore. But times are changing, and in this context of performance, I would like to talk with native Java applications based on Spring. So we will focus on Spring apps because most of us probably work with Spring. My name is Krzysztof Gonia. Currently, I'm working as a Java tech lead at CDQ. And today we will talk about GraalVM. We'll talk how this works, pros and cons, how to work with native with frameworks. We'll see some performance tests and we'll discuss some use cases. So let's start with the basics. So to run our Java application, we need to have JRE with JVM. So this is, we need to install it, have some basic environment to run our compiled code. But to write our code, we need to have JDK, some additional tools to write and compile and ship our Java programs. So what is GraalVM? GraalVM is basically a JDK with some additional components. So GraalVM provides his own JIT compiler, just-in-time compiler. It supports multiple languages. So with Graal, you can run Java and Python together in one program. But today we will focus on ahead of time compiler, which allows us to compile our Java code to native code. So native code that can be run without JVM will get the executable file that we run just on our system without any additional environment like JVM. So what's the difference between just-in-time and ahead-of-time compilation? So when we have our source code, the compiler compiles it to the bytecode. So usually we ship it as a jar file. And then in JVM, this bytecode is compiled to change to native machine code. So back in the days, Java had this marketing phrase, run once, run everywhere. Yeah, so you can write your Java code on your Windows machine, and then you just ship the jar, and it can be run on the Linux because the JVM will took the JVM and JIT specifically will handle all things that needs to be done to run it on the Linux or macOS, for example. So with GraalVM, we go straight from the bytecode to the native machine code. So we don't need to provide the JVM because we'll get the executable file specific for some system. So let's consider this simple hello world. So probably every one of you wrote such program when you start your programming journey with Java. And question to you: have your answer in the mind? You will get the answer later. How many classes are needed to run hello world in Java? So how many classes from the JRE we need to run this program? And let's see some demo. Okay, my mouse is working. Okay, so we have this this main class. You might notice that. Oh, okay. Okay, I probably need to. Okay. Sorry for that. Okay, so we have this simple main with just hello world. You might notice that there is a POM file, but there is nothing interesting in it. So basically, this is just this main class. And I have some build script. And I have one for the Windows and second one for the Linux, just to prove that it's possible to have both, that it will work on Windows and on Linux. So two first comment you probably are familiar with. So Java-C just compiled our source code. Then with jar command, I will just package it to the jar file. And then we have this new command comes for GraalVM native image, which just generate executable from our jar file. So let's run the Windows version. First, I'm in the wrong catalog. Okay, and you can see that some process started, so we get some info about GraalVM version, Java version, and Graal starts to analyze our code and compiles and link it to the native executable. So let's see if this worked. So we have exec file that prints hello world. So it's executable that you can ship to anyone that have Windows, and it will just run without any Java environment. Let's do the same with the Linux version. So configure it on the Linux is much easier, because you basically need to install GCC and some other packages, and configure it on Windows is possible, but it's painful because you need some dependencies additional to compile the native, and usually you need to install some part of Visual Studio Code and so on. But I just want to prove that it's possible, and we have also hello world for the Linux. So how that's possible? So GraalVM takes our application code, our libraries, and just analyze it search for the classes that we are using, checks what methods are needed to run our code. It also built in some JVM called substrate VM. So it's still the Java code. So we need, for example, garbage collector to remove our things from the heap. So it's not like we don't, it's not the Java. It's still the Java. It works like Java, so we still need the garbage collector. So some things are shipped and built in within our executable. And what does GraalVM also does? Besides analyzing our code, it does also heap snapshotting. So it runs based on the analysis. He might initialize some objects during the build time. So it will be not initialized after startup, but they are already initialized in the build time, and it will be, thanks to that, we'll have also faster startup. So to answer the question, how many classes we need? So here we have the results of this analysis that GraalVM did, and we see that on the Linux version we need 2100 classes to run this code, and on the Windows version we need 2800, which is here 61% of all available classes. So we can see that the basic JDD for the Windows is bigger than for the Linux. So in the executable, we will have only on the Windows 74% of all our classes and only 50% of all fields and 32% of all methods that are in the. So rest that are not reachable, GraalVM states that they are not needed in our code. We don't execute them. We don't need them. So they are removed from, or maybe not added to the executable. So what are the benefits of that? So we have faster startup, and we will see it's how much faster it is. We'll see that on the Spring example. We have low memory footprint and small packaging. We'll talk more about low memory footprint later. But there are also some disadvantages, like we don't reach the peak throughput and max latency. Why? Because code runs faster the longer it runs. So our little turtle becomes this guy after our code runs in the time. Why? Because the JIT compiler do the optimizations to our code. So when you use your code, you have a lot of different paths that might be executed in your code. You have if statements and other things that cause that your code might be executed differently. So JIT optimized your code to how your code is executed. So after time, your code will be executed faster with JIT compiler. So this is why the JIT has higher peak throughput and higher max latency. So we had the simple program, and GraalVM assumption is it's closed word So we need to have information about all classes that we will use in our code during the build time, which might be a problem in the frameworks like Spring because they're using reflection, dynamic class loading, Java native interface. So what's the solution for that problem? Solution is use the newest version of the framework. So it's possible to build native image with Spring Boot 2, but it's painful. It's much easier with Spring Boot 3, which has the support for AOT. So also frameworks like Micronaut or other that I forget the name has this support and had this support even earlier than Spring because Spring is big legacy project, so they must adjust to the changes. But with Spring has this Spring AOT separate project that will generate all information for GraalVMs. And what is interesting, it generates all the beans as just Java sources. So Spring creates bean in runtime. You probably, if you are using Spring, you know those. It does it by reflection. So with Spring AOT, it will create the Java code, your beans as Java code, so it can be just compiled and treated as a normal code. So another question, how many times faster is native startup for Spring Boot? So have your answer in mind, and we'll see some demo. Okay, so I have this Spring application. It's Spring with some MongoDB. And okay, I need to run Docker. And it's basically just standard POM file for the Spring app. What is new? We have this plugin, native Maven plugin, which is needed and which help us to build this native code. Okay, I will just run the Mongo container. So we have simple book model with some controllers, so we can save this book and get information about this book. And we have also simple hello world controller. So very simple Spring application. And let's compile it. Awesome. Okay, I will run the command and then I will show the script. Okay, so with Maven, if it's even easier because we just call those two commands, and it will handle all the stuff for us. So let's see what's happening here. You can see that it's a lot more happening than with this simple application we had, because as I mentioned, the GraalVM needs information about all libraries, our code. So, you know, when we got the Spring dependencies, some starter, it has a lot of other dependencies in it. So we need to have information about all those classes. So you can see that, okay, those are tests. And here we have process AOT stage in the Maven. So it runs our application in a special way that allows to collect all informations about our beans. And here is a long list of libraries. And then when the information is collected, the process look very similar. Here are a lot of stuff he needs to set up on the fields because normally they are used by reflection. Now it must be available during time. And after that, it's just compiled. So you can see that we have a lot more classes available, and almost 90% of them are used in our application, at least according to the GraalVM. Let's look also about some generated. It's not that. Okay, so you can see that Spring generates for us the bin definitions as a Java code. So it's not anymore created in the runtime. Spring has module to generate Java classes, our beans as Java classes, and then it can be compiled. So also our beans that we use, like for example, these controllers are also generated the same way, but I need to, okay, this is the way. So our controller is generated as a Java code. So no more generation beans in the runtime. Is all Java sources before we run our program. As you can see, it's takes for the Spring application. It takes much more time to compile than for the simple one. And now we have native Spring app that just started in 0.8 seconds. So I will not compile the version for the Windows just to not waste time. So I will just run already compiled one. Okay. No. Why? Okay, this is unexpected. Unable to start web server. Why? Why? Yeah, but I already closed that one, so it should start. Okay. Anyway, so it's the matter of the used port, not because of the, okay, others already in use. Okay, so it's matter of the port, not of the some error with the compilation. And so okay, I didn't run the standard jar file with the JVM, but on this machine it's starts around 1.7 seconds. And this is a native start on the Windows version. So for some reason, this native compilation works better in terms of app startup, works better on Windows than on Linux. I don't know why, but this number is taken from the Windows version, not from the Linux. So for the Windows version, it's around 14 times faster startup, and 7 to 27 smaller artifact wider range, because I'm thinking about shipping it as, for example, as Docker image. So with Docker image, you need to not just ship the jar file, but you need to also ship the whole JRE. So you need to have the environment to run your jar file. So depends on which image you will choose. You will have different size of the Docker image. But it's not just the comparison of the executable versus the jar file, but you need to remember that you need to ship the whole environment. So when you have the exec file, you need some basic Linux image, and that's all to run your app. But if you want to run jar file, you need to ship the whole environment. So why exactly native is faster? So when we have the starting the new app, we need to initialize the JVM and load all the classes that will be used in our app. Then we have the startup of our app. So our classes start running. If we use framework like Spring, he needs to do his initialization. So we have this ramp up phase, and then apps stabilize. So with AOT, this whole process, that the startup process, is basically done during the compilation. So we don't have this big initialization, because it was already done, and it's all the classes that we need to have already shipped in the exec, so there is no class loading. So let's see. I don't know if we'll not have some interruption because of this problem with the port, but let's see. So I prepared this simple script that will just start perf to measure some performance stats, and then we'll measure the CPU usage and memory usage by the native image and by the standard JVM plus jar. So we will wait till app is started, and then we will simulate some load, which is just 20 calls to the hello endpoint. And then we will have the charts to compare. Let's see if this will work. Okay. So now we have this simulating load. So it does this 20 calls. The process is shutting down, and we will do another for the native version. Similar process, and we will compare the results. Okay, so the left axis is and the blue line is the CPU usage. So 100% is one core. So we see that at the start you use almost 2 cores. This is the moment from 0 to 5 seconds of the initialization of the app. So we have this spike. We also have spikes in memory usage. So right axis, the orange one, and the memory also stabilize around 230 megabytes. And let's see results for the native. So for the native, we use just 10% of the CPU at the start, and memory is just stable from the beginning. Why? Because when we use our application, we create new objects that are allocated on the heap. So heap usage will be very similar in both versions, but our application, the memory consumption, and we see the memory is also memory consumption is much lower because it's around 100 megabytes. So in this case, it's almost twice less. So our memory consumption of our app is not only what we allocate, but also some additional processes like JIT. He needs to load all the classes in the memory, and also this JIT optimization that he does during runtime. Also, he needs to store somewhere information about how our classes are used, how our code is executed. So all these additional things needs to be stored in the memory. So with native image, we don't have this JIT process. So we don't need to, we don't allocate this additional resources. I also did some very basic tests. Let's call it a load test on this book endpoint with 800 users that are constantly growing and sending requests. And here are response times. So the green one is the median response, and the yellow one is 95% time. So we can see the native is even faster here, and native also have higher total requests per second. But take those numbers with a grain of salt, because it will depend on the machine system. We already saw that there is, even on the same machine, there is difference between Windows version and Linux version. Maybe it's because I'm using here WSL, so it's not typical Linux, but still there will be version between machine system, GraalVM and framework version, and also some additional optimizations. Because I ran this compilation without any additional optimizations, but there is a lot you can enable. So some rules you can have in mind that based on knowledge I gather and my experience, that native will always start faster and has a lower memory footprint, but peak performance and throughput depends on a lot of variables, so you need to measure that. And there is one nice thing called profile guided optimization, which will allow us to get similar throughput like with the JIT approach, because with the profile guided optimization, we collect how our code information, how our code is executed, and then we can build this image with this instrumentation, run this image, collect the information, it will be saved in the profile file, and then we can use this profile file to compile our code. So this native code will be adjusted to how our code is used, so then we should have get much better performance, because it will be similar to how JIT operates. So, of course, there are some drawbacks. It's not the free meal. So you can see that I cross out some things because I prepared a first version of this presentation almost a year ago, and there was some problems. So the Oracle team responsible for GraalVM solving some of those problems, also the community solving this problems. So there was a problem with Spring profiles. Now it's solved. Also, there was only one app container that was supported. Now there are few. There was problem with Java agents. Now we can use them with some limited functionality in some cases, but they are not so big blocker as it used to be. Unfortunately, there are some libs that can't be compiled, and there are a few, but probably you all know the log4j. So it works well if you choose the logback for the as your logger in your, for example, Spring application, and I think the logback is the default one for the Spring. But if you choose the log4j, sorry, you can't compile to native. So you need to change the library for logging, or it's just not possible because how the log4j is coded. So it's also possible to do this without framework, but it's much painful. So frameworks nowadays have nice support for AOT. And we also need to spend additional time for native compilation. So we have faster startup, which you need to give for the compilation. So if you have app that you deploy every 1 hour, maybe it's not worth it. Also, JMX limited heap dumps possible, but with different tooling and similar for debug. But I assume you don't debug on production, so usually it's not needed. So on your local machine you can debug it as a Java code, but if you want to debug the built image, you need to use the tools like JDD. So what are use cases? So all things where you need fast startup time. So for example, Cloud Lambdas. So instead of build your Lambda as a Java, you can just compile it to the native and deploy it as a native code. So if you do some cloud stuff, you probably know that Java with Lambdas, the biggest problem is the startup time. So you can reduce it by compile to native. Auto scaling, when you have big load on your app and you want to fastly create new nodes, native will be faster to start up new nodes. Short-lived apps, this is very interesting because the GraalVM offers the special garbage collector that does nothing. So if you know that your app will live short and you don't need to clean up a heap because you have enough memory, so all things will be gone when your app will stop working. So you can speed up just by using garbage collector that does nothing. Desktop apps with problems, but possible. So nowadays Java is not popular as desktop apps, but now you can just ship the exec files. So no need for install the whole JVM on someone's machine to run your app. And also the CLIs, it's nice because you can build CLIs that will start up fast. And here is an example built by one of the Java heroes. So command line for Kafka Connect. And when you need lower network footprint, smaller containers, so the sending across network is also faster. So migration tips, the most important, update your framework to the version with native image support. So don't try it with the Spring Boot 2. It's too painful. Just migrate to 3 and then try. So small recap, we learned what's GraalVM, how to create native Java apps, pros and cons of using native Java. And moving to Java is almost effortless. It's all depends on your current setup, because for some apps it will be easy to compile. For some there are blockers, like those libraries that are not supported. For sure additional work for your DevOps, because build pipeline will be different. And for sure money saver for your client or for your company. So thanks for your attention. If you want to find me, you can find me on LinkedIn or the Twitter X. Or in few weeks, the presentation will be also available on my page. So we don't have time for questions. So if you have any, please come to me after the talk. Thank you.